Hey everybody, it's Mr. Campbell here with Mathematical Anarchy, and today we're talking about finding extrema and exploring first differences. To start off, we'll recall that the average rate of change is a ratio that compares the change in one thing to the change in another thing. When our average rate of change is negative, our values are decreasing. When our average rate of change is positive, our values are increasing. And when our average rate of change is zero, it's possible that our values are constant. To think about extrema, we can break it down very simply as minima and maxima. The minima are the smallest values that we have, and the maxima are the largest values that we have. Thinking about the largest and smallest values out of all of the values, these are going to be called the global max and the global min. And smattered in between are going to be what we call local maxes and local min values. There's some patterns you might notice. If we take a look at where our values are increasing compared to where our values are decreasing, we should notice that wherever we change from increasing to decreasing, we have a maximum. And wherever we change from decreasing to increasing, we have minimum values. And on the endpoints, we're going to have to determine up to that point, was it increasing or decreasing? So taking a look at an example, the global max and the global min are the easiest to find using a graph. For the Arizona monthly deaths in 2020 represented in red, the global max is 7,903. The number of deaths in July. The fewest deaths occurred in February. Looking at the average of the 5 years prior to 2020 represented as an average, we have to look a little harder, but the global max, the most deaths occurred in January. The fewest deaths occurred in September. But the question is, are there local min and local max values smattered in between? We can see February is a local min, March is a local max, and outside of that, it's hard to tell. But one thing we could do is use this idea of knowing where our function is increasing and decreasing and comparing where does it change from one to the other. We might be able to locate any other extrema that exist. One thing we're going to have to do is figure out, are the deaths increasing or decreasing from month to month? And one of the things we can do is explore what's called first differences. If I take 4,929 and subtract off 5,680, that'll tell me how many deaths have occurred more or less from January to February. And I could do the same calculation between each month and produce what's called the first differences. Now, looking at our differences for the 5-year average before 2020, I can see from January to February it's negative, and then February to March it's positive. So the sign has changed right here, and we can see that does represent a minimum. We can also see the sign changes from March to from between February and March, from is where it's positive, to negative between March and April. We can see that represents a max. The next place where it changes sign is in June, where it goes from negative to positive. So it goes from decreasing to increasing. This is a min. From decreasing to increasing in September, that's a min. And then it continues increasing, which makes December a max. Looking at our first differences for 2020, there's actually only one sign change. And that happens in February, because the number of deaths started increasing in February and haven't stopped increasing for the data that we have here. So that tells us that our global min is the local min, our global max is the local max. There is one more max on the left-hand side here. Okay, again, since it was decreasing from there, it was maximum value. Now, you should notice that we're looking at this month to month. We've looked at the change in the number of deaths, and we might compare that to the change in months. And in doing so, we'd be looking at the rate of change, delta D over delta T, the change in deaths over the change in time, and that would measure the number of people per month, okay, the change in the deaths from month to month. For instance, from June to July, I could take 1,470 people over 1 month, and that gives me 1,470 people per month. So what we find is that the first differences are actually a representation of our average rate of change, as long as we understand that we're comparing the change in the outputs over the change in the inputs, even if they're only 1 month increments. So this idea of first differences gives us a lot to work with. We use subtraction to show how the inputs and outputs are changing. And we can use this to explore the average rate of change. In our last example, we're going to take a look at how we can use this information to explore first differences and the extrema given data and not having a graph. Having a graph, we can visually look at and find the maximum and minimum values. But using data, we're going to have to look through all the values in order to find which is the largest and which is the smallest. So let's take a look at how we can use first differences to make that easier. If we take a look at the change in time, it's increasing by 1 day. Now finding the differences for our temperature to figure out how our temperature is changing day by day, we see sometimes it's positive, sometimes it's negative. But again, we're talking about the average rate of change in temperature over change in time, measuring degrees Fahrenheit per day. So this takes 7 degrees Fahrenheit from the 3rd to the 4th, that's 1 day. Again, that gives us a positive 7 degrees Fahrenheit per day, telling us that the values are increasing. So wherever our first differences are positive, our values are increasing. Wherever our first differences are negative, our values are decreasing. And so it gives us a real easy way to see that from the 3rd to the 4th, our differences change from positive to negative. So from increasing to decreasing, this tells us it's a max. Right? Positive to negative is a max. And our other value is going to be 92 degrees, because we can see it goes from negative to positive, right? Decreasing to increasing, which means this is a minimum. So in terms of finding extrema, one of the things that we can do is look for a sign change in the first differences. For minima, decreasing to increasing, the rate of change is going from negative to positive, we have a minima. For our maxima, we're going from increasing to decreasing. Our rate of change is going from positive to negative. And again, that's a max. So we've explored extrema and how to use first differences. So try the practice. Write down any questions that you might have, and come prepared for any support that you might need in class. Good luck.